Good evening, my YouTube viewers. It is Crystal here, and I'm just here this evening because I wanted to give you another code review on label propagation. So label propagation is one of the three methods in sklearn that cover semi-supervised learning. So in a previous code review, I covered the self-training classifier. So in this video, we're going to cover label propagation. And so I wrote the program in Google Colab, which is a free online Jupyter notebook hosted by Google. And so it's a very good Jupyter notebook, and it's very good for data science projects. The only problem is it doesn't have a very good undo function, and as a result of that, you have to be careful not to delete or overwrite valuable code. If you do happen to delete or overwrite valuable code, you can come over here in the save history, right here in the save history, and there's a possibility that you can retrieve the code, but it's not always possible. And one time I was working in another computer, and I saved the work and it didn't save properly, and I lost everything I had done, and so I had to redo it, and that wasn't very fun. So I just wanted to bring that to your attention. So after we have created the program, what we want to do is we want to we want to import the libraries. And so the libraries that we're going to import are NumPy as NP, and that carries out numerical computations and it creates NumPy arrays. Then we want to import pandas as PD, and that carries out, it creates data frames, and it also carries out data processing. And you can manipulate data frames as well. We're going to import matplotlib.pyplot as PLT, and so what that is a graphics package, and it enables you to plot the data points onto a graph so you can visualize the data points. And we're going to import the warnings so we can ignore the warnings, so you won't be getting loads and loads of warnings on your computer screen. And then what we're going to do is we're going to use a data set that from Jason Brownlee. Jason Brownlee has his own website, but the data set that we're going to be using is the Pima Indian's diabetes data. And so this particular data set doesn't have any headings, so we're going to create our columns of pregnancies, glucose, that's diabolic blood pressure, and so I got DPB instead of DBP, but it's diastolic blood pressure is what it is. Skin fold, that's like your fat on your skin fold. Insulin levels, BMI, that's body mass index. Pedigree, I'm not sure exactly what that is. Age, and your label is your target. And so you have 768 rows by 9 columns. And so what we're going to do is we're going to randomize the data frame. So df equals data.sample, frac equals 1, random state equals 40. So what you're doing is you're randomizing 100% of the data frame. df underscore copy equals df.copy. So you're going to make a copy of the data frame, and the reason why you have to make a copy of the data frame is because when I was working on this program, even though it wasn't supposed to, the value counts were not working correctly, and so in order to keep that from happening, we just make a copy of df. Y_orig equals df copy label, so that's your label, and that's the original label after it's been randomized. And then you can see your df, which is, and you can see over here in the index, over here the index rows have been randomized, which is what you want to see. So we're doing a value counts on Y-orig. So you have 500 of 0, that means they don't have diabetes, and 268 of 1, that means they do have diabetes. And we're going to check for any null values, and you don't have any null values, which is good, so we don't have anything to impute. And so now what we're going to do is we're going to use Matplotlib to plot the data set of the Pima Indians onto a graph so you can see a two-dimensional display of this. And what you can do is it's showing you the first two columns. So df.iloc0 is column number 0 and df.iloc1 is column number 1. So really it's only showing you the first two columns and not all of the columns, and it's giving you a two-dimensional array. And marker is 0 and C equals Y original, so that's your original values. And then after we look at the 2D array, I thought it would be really great to give you a 3D array as well. So this is just the code for a 3D array, and you can see where it sits in memory. So now what we're going to do is we're going to make the random number generator equals np.random state 42. So we've got a random number generator, and now what we're going to do is we're going to randomize 60% of the data frame. 60% of the rows of the data frame are going to be randomized, and the ones that are randomized are going to be giving a value of -1. So a -1 is going to tell you that these rows are unlabeled, because what we're doing is we want to unlabel the rows. The reason why we're going to do that is because label propagation is employing a semi-supervised learning technique, whereas a small portion of the rows are labeled and the rest of them are unlabeled. So we're saying 60% are unlabeled and 40% are labeled. So we look at DF value counts. You can see you've got -1 is 461, 0 is 181, and 1 is 126. So -1 is part of the value counts. And we're going to define our X and our Y variables. Your X is your independent variable, and your Y is your dependent variable. So Y is going to be the last row of the data set, and X is going to be all of the rows of the data set except the last row. And so you can see that X.shape is 768 by 8 columns, and Y.shape is 768 columns. So now, after we have defined our dependent and independent variables, now we're going to define our model. So from sklearn.semi-supervised import label propagation, LP model equals label propagation dot fit x y, ypred equals LP model predict x, and then you've got your ypred. So now we have all our 1s and 0s, which is what you want to see. You don't want to see any -1s. The -1 is just telling the model that it's unlabeled. And so now we're going to check the accuracy, and we're using a function that I made up to check the accuracy, and we've got an accuracy of 81.77%. And now what we do is we put it into a confusion matrix. So you have 498 zeros, and 2 of those 498 zeros are false negatives, and then you have 130 negatives, and 138 of those negatives are false positives. So, and then what we're going to do is we're going to create a data frame. And when we create the data frame, then what we're going to do is we're going to compare the true values to the um, uh, predicted values. And what you can do here, just to show you, because the thing about semi-supervised learning is it's supposed to give you a more accurate prediction than you would get with unsupervised learning. But let's see, we're just going to take this here and we're going to make half of them unlabeled and half of them labeled, and we're going to rerun it. Okay, and then so when we rerun it and we check our accuracy has improved to 84%. So the more labeled data that you have, the higher your accuracy is going to be. And so if we decrease our accuracy to 70%, so 70% of the labels are unlabeled and 70% of them are labeled, we'll run it again. And your accuracy is 76%. So you can see that the more unlabeled rows you have, the lower your accuracy is going to be. So I'm going to go ahead and conclude this video because I've covered everything I want to cover with regard to label propagation and semi-supervised learning. So this is going to conclude the video. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video. And I look forward to making more code reviews for you in the future.